let's use what we know about simplifying radicals to rationalize a denominator. Rationalizing a denominator means no radical signs in the denominator. The denominator cannot have any radical signs. So let's start this problem here. And we have the quotient property of radicals. So I'm going to change this into the cube root of 8 divided by the cube root of 3y squared. Well, I'm going to start off real quick making my life easier because I know that the cube root of 8 is 2. So that's 2 divided by the cube root of 3y squared. Well, 3y squared is not a perfect cube, but I have this cube root down here. So what I need to do is I need to figure out what am I going to multiply the cube root of 3y squared by in order to get rid of the radical sign. And I have to remember here that, for example, the cube root of x cubed is equal to x. So I want to get some perfect cubes underneath that radical sign in order to get rid of the radical sign. So actually, rather than a multiplication sign right here, let's use an equal sign because I want to split this up a little bit. So I'm going to leave my 2 on the top, but I'm going to have in my bottom here the cube root of 3 times the cube root of y squared. Okay? Now, I would like to get rid of the radical sign for this cube root of 3. Well, I'm going to do that over to the side here. If I have the cube root of 3 and I'd like to get rid of the radical sign, how about if I multiply it by the cube root of 3 squared? Then, using the product property of radicals, I can put this in one radical sign. I'd have the cube root of 3 times 3 squared. And since we know that 3 is really 3 to the first, that's the same thing as the cube root of 3 to the third, which, you know what, that looks really ugly. It's 3 to the third. Let's make it look like 3 to the third. I don't want anybody to think it's 33. So 3 to the third power, that's a little bit better. And we know that that's equal to 3. So if I multiply my denominator here, if I start off to multiply it by the cube root of 3 squared, then I know I'm going to be able to take care of this piece over here and get that out of the radical sign. Well, let's take a look at the cube root of y squared. How am I going to get rid of that? Well, I have here the cube root of y squared, and I know that if I multiply that by the cube root of y, which is y to the first, then that's going to be the same as the cube root of y squared times y to the first, which is the cube root of y cubed, and that gets me y. No more radical sign. So again, I want to multiply the denominator here by the cube root of y. So if I do that, this is going to be multiplied times that and get rid of the cube root of 3, and this is going to be multiplied times that and get rid of the cube root of y squared. I mean, I don't want to confuse anybody here, but I mean, really what this is going to be, this denominator here, would be like having the cube root, one big cube root, of 3 times y squared times 3 squared times y. And, you know, I can reorder these any way I want. So I could, because it's multiplication, that would be the same as the cube root of 3 times 3 squared times y squared times y. And then you can see that it's the cube root of 3 cubed y cubed, which is going to give us 3y. We'll get to that in just a minute. So that's why I'm going to multiply these two things times this denominator here. But I can't just multiply the denominator because I feel like it. If I do something to the denominator, I have to do it to the numerator. So really, I'm going to multiply my numerator by the same thing, the cube root of 3 squared times the cube root of y. And if you look at it, you know, like arithmetically, I'm multiplying this blue piece here times this red piece here, and you can see that this red piece is just one thing divided by itself, so that's 1. And we know we can multiply anything times 1 and not have it change the thing at all. We're just kind of changing the way it looks. So now in my numerator, I have 2 times the cube root of 3 squared times the cube root of y. And in my denominator, because I've multiplied that times that and that times that like we did just a minute ago, in my denominator, all I have is 3y. So I have rationalized my denominator. In order to make this look a little bit more elegant, which you should really do, this would be 2 cube root of 9y divided by 3y. So just make this 3 squared into 9 and get rid of the multiple cube root signs, have one cube root sign, and this is the answer, and you have rationalized your denominator.